All right, now we are looking at 3.3, completing the square. We looked at using square roots in the, what was that, section 1, and that only worked whenever we had a polynomial where it looked like x squared equals some number like 25. We were able to take a root and we got that x was plus or minus 5 from that. But now we're going to be looking at ones that we can't do that with. So number 13 here. We're supposed to solve using square roots, and for starters, I'm going to look, and this is a little bit different than normal, I'm going to look at trying to factor this. Now, in section 1, we would have tried to subtract the 25 and get it equal to 0, but in this one, it's set up really nicely such that the left side is going to factor. Whenever I factor that, I would have, well, you know what, let me show out factoring. We're going to take our 9, and we'll break that up into a 3 into 3. Those add up to be 6. So we'll say x squared plus 3x plus another 3x plus 9 equals 25. My first two terms and my second two terms I'm going to look at separately. I pull out the x in the first one and I'm left with x plus 3. I pull out the 3 in the second one and I'm left with an x plus 3. Then that equals 25. Now I can pull out the x plus 3's, and then left over I have the x and the 3, so x plus 3, and that equals 25. Now here I have x plus 3 and x plus 3, but what I can do is I can say, well, this is x plus 3 quantity squared is 25. Right? Whenever you have an x times an x, you can say x squared. Right? To be squared means multiplied by itself. Now that I've got this, I can take a square root, and I'm left with x plus 3 equals plus or minus, and the square root of 25 is a plain old 5. So x equals negative 3 plus or minus 5. You know, and just to finish it off, because the 5 is a nice number, it's easy to deal with, we can say negative 3 plus 5 and negative 3 minus 5. Now, if it wasn't a plain old 5, say it was like root 13 or something like that, then this would be our answer right over here. But since it's just a plain old 5, we can add it up and we can get 2, and we can get negative 8, and those are going to be our answers here. Now, going back to this, going back to like the beginning, some people noticed that these problems here, whenever this left side is set up very nicely, it'll always break up to be something like this, where you get a quantity squared. And what people noticed was that this last term, as long as it was the middle term 6 divided by 2 and then squared, then it would factor really nicely. So this is the formula that's going to be down here. It's b over 2 squared. It means that if the last term, the c, if the c was the middle term 6 divided by 2 squared, then it would factor really nicely. So let's just do this. 6 divided by 2 is 3. Squared gives me 9. So somebody noticed that pattern there. And we're going to use that pattern to be able to solve some problems here. Here's our little blurb. If you want to read that, you're welcome to. I'm going to go ahead and just go right into number 14. They're just wanting us to complete the square here. So completing the square is the process of finding the c value that makes it factor really nicely. So I'm going to say I've got 18 or x squared plus 18x, and then I'm going to put a plus and I'm going to have a blank there. And I'm going to find that c value. So our b is 18, and I need to find out my c. Now we know that c is going to be b over 2 squared. My b value is 18 divided by 2 squared. 18 divided by 2 is 9 squared is 81. And what that tells me is that if this last blank is an 18, then it's going to factor really nicely. And let's go ahead and factor this. Oh, not 18, 81. Good grief, 81. There we go. So because this c is an 81, it should factor really nicely. And let's go ahead and do that. If we take 81, we look for two numbers that multiply to be 18. That's going to be 9 and 9. I think I might have just said that wrong. The two numbers multiply to be 81 and add up to be 18. I'm sorry if I said that wrong. Now I'm going to take and I'm going to have x squared plus 9x plus 9x plus 81. These two middle guys add up to be b. So now I'm going to look at the beginning two. I can pull out an x, and I'm left with x plus 9. And then the last two, I can pull out a 9, and I'm left with x plus 9. Now they factor to be an x plus 9 times x plus 9, which is x plus 9 squared. Now, if you want to, you can jump from the very beginning there to the very end here. Okay, we need to know how to factor, we need to know how to do these steps, but on these, because it follows such a rigorous pattern, I'm okay with us skipping some of that. And the way that we're going to get this guy down here is that this 9 is always going to be b over 2. Plain old b over 2, not squared, just plain old. So the blank is b over 2 squared. But then the piece that is at the end is just going to be a plain old b over 2. Our b was 18, and this guy was 9. If we scroll up a little bit, our b was 6 right here, and down here we had x plus 3. 6 divided by 2 is 3. So let's look at doing another one of these. Now this little blurb here talks about example 14 and how example 14 did not have an equal sign in it. It was just a little expression. Now in 15 we're going to have an equal sign, and we're going to have to make sure that we keep our equation balanced, right? We can't just add something to the left side or the right side. We have to add it to both sides. So right here for starters, I'm going to add the 7 over, and I'm going to have x squared minus 14x equals 7. And I left a little bit of a blank there because I'm going to put my blanks there. Now the left side here, I'm going to treat just like what I did above, but I still have to have my equal sign, and then my 7 and my blank on the right. Right, so I've got a blank on the left because I'm adding something. I've got to add the same thing on the right side to keep my equation balanced. The piece that goes in the blank is always going to be b over 2 squared. My b value is negative 14 divided by 2 squared. That's going to be negative 7 squared, which is positive 49. Now this left side, we made it such that it has to factor, right? And if you wanted to, you can go through and factor it, but I'm telling you, it might be a little bit easier just to use the pattern that it's going to be x minus 7 squared. You take this middle guy, the negative 14, and you divide by 2 to get the negative 7. On the right side, we're going to have, what is that going to be, 56. Now this problem here is something like what we had in section 1. We should be able to solve that. We take a root on the left and the right side, and we'll have x minus 7 equals plus or minus root 56. Now we want to see, can we break the 56 apart? And I'm thinking that we can. We'll divide by 2 to get 28. And then we'll have 2 and 14, 2 and 7. With this being a square root, we circle pairs, and then we have a couple singletons left over. So we're going to be having x minus 7 equals plus or minus. The pair comes out front, then we have our root, and then we have 2 times 7. I'm going to do two things in this next step. I'm going to put the 2 times 7 together to make it a 14 again, and I'm going to add this 7 over. So we're going to have 7 plus or minus 2 root 14. And that is going to be our answer. There we go. First thing that we did was we got the quadratic term and the linear term together and alone, right? So I added that 7 over. Then I put in my blanks, and then I did the process of completing the square. After I did that, I was left with this guy right here, and I took my square root and I solved using plain old square roots. Let's look at number 16 here. Now, before I subtract over that 49, I'm going to check and see, is this set up ready to factor? is the c b over 2 squared? Right, I'm going to see, is the c, the 49, is that b over 2 squared? And I think it's going to be. Let's check. 14 divided by 2 squared. Right, I'm using 14 because that's my b value. 14 divided by 2 is 7 squared, which is 49. 49 is my c value, so someone's already set this up for us. And we can factor straight to p plus 7 squared equals 2. Now I'm going to have p plus 7 equals, taking my root, plus or minus root 2. Now 2 is a prime number, it doesn't break apart nicely, so we're going to have p equals negative 7 plus or minus root 2. And that's all we got to do. That one we didn't have to use the blanks because it was already set up. Right over here, I figured out that it was already set up nicely for me. My c value, the 49, was what the c value needed to be for completing the square. All right, number 17. This says to complete the square and factor. Now this guy doesn't have an equal sign, so we don't have to deal with our blanks on the left and the right side. I'm just going to put my plus blank right there. To figure out what goes in my blank, I use b over 2 squared. My b value is negative 4, so negative 4 over 2 squared. That's negative 2 squared, which is 4. So I got a 4 in my blank. Now it's ready to factor, and my pattern tells me that it's going to be y minus 2 quantity squared, right? The 2 came from negative 4 divided by 2. And that's going to be my answer, the y minus 2 squared. Alrighty, number 18 here. I'm going to subtract the 5 and then add in my blanks. So I'm going to say x squared plus 8x plus blank is negative 5 plus blank. Right, I subtracted that 5, and whenever it went to the right side it was negative. And then both spots got blanks, right, the left and the right side. Now I need to decide what goes in my blanks. So the blanks get b over 2 squared. My b value is 8, so I get 8 halves squared. 8 divided by 2 is 4 squared, which is 16. So I get a 16 in both of my blanks. This left guy here, we've made it such that it has to factor, right? We did the process of completing the square. It has to factor. It's going to factor to be x plus 4 quantity squared, right? And that's that middle guy divided by 2. Now on the right side, negative 5 plus 16 is going to be 11. Now I take my root of both sides, and I get x plus 4 equals plus or minus root 11. And I subtract my 4 and I get x equals negative 4 plus or minus root 11. And there we are. Number 19. They've got the 3 already moved over for us, so we're ready to put in our blanks. R squared plus 5r plus blank is negative 3 plus blank. And then in my blanks, I put b over 2 squared. My b value is 5. Now we might be seeing the kind of crappy part of this problem is that we have a fraction here that won't reduce, right? 5 halves. We don't want to make it a 2.5 because we don't want to deal with decimals. But because it won't reduce, I'm going to leave it as a fraction, and we're going to have 25 over 4, right? I squared the top and the bottom. So my blanks both get 25 over 4. Now that's kind of scary. And on the left side, the only way we're able to really factor that is to know that we have a pattern. We're going to trust our pattern. It's going to be r plus b divided by 2. So that's going to be 5. Oops, that's a b. I mean, I guess my b is 5, but 5 divided by 2 squared equals, and then we have that chunk over there, and I'm thinking that's 13/4. But I'm going to check it with a calculator just to make sure. Oops. Yeah, 13/4. Now I take my root, and I'll have r plus 5 halves equals plus or minus root 13 fourths. I'm going to try to pretty up my root, so I'm still going to have the r plus 5 halves equals, I'm going to have my plus or minus, and I'm going to break it up over the fraction. I'm going to have a root 13 up top, and then my denominator, I'm going to have a root 4. So that's 2, right? The square root of 4 is 2. And then I'll subtract my 5 halves, and I'll have r equals negative 5 halves plus or minus root 13 over 2. Now some people would leave the answer like that, but because I have common denominators, I'm going to put it together. R equals negative 5 plus or minus root 13 all over 2. And there's our answer. Looking at number 20. Number 20, we're going to have another fraction. It's going to work very similar to our previous one. So I need to add in my blanks, and I also need b over 2 squared. Well, b halves squared is going to be negative 9 divided by 2 squared, which is going to be positive 81 over 4. So for this problem, I'm going to have m squared minus 9m plus blank, and I've already gotten my blank, he is 81 over 4, equals negative 2 plus blank. This guy on the left, we've made it such that it has to factor, right? We completed the square. And I'm going to have m minus the 9 divided by 2, so negative 9 halves squared equals, and I didn't follow this blank in, 81 over 4. And I'm going to check that out in a calculator. 81, I guess it would be minus 8 with common denominator, so 73 fourths. Now I'll take my root, and I'll have m minus 9 halves equals plus or minus root 73 over 4. Prettying that up, I'm going to break my radical over the fraction. So I'll have m minus 9 halves equals plus or minus root 73 up top, and then the square root of 4, which is 2 in the bottom. 73 we try to break apart, but I'm thinking that he's prime. So I had the square root there, square root of 73 over the square root of 4, which is 2. And then one of my last steps is going to be to add that fraction over, and I get m equals 9 halves plus or minus root 73 over 2. And then common denominator is 2, and they already have the common denominator, so I can put that together. M equals 9 plus or minus root 73 all over 2. And that's going to be our answer. Now, one thing that we did not have on any of the notes problems was any complex numbers, any imaginary numbers. It might be that on the homework that this term, or that piece there, will be a negative number. That would mean that we'd have a negative under our root down here, and we'd have to have an I in our answer. Just remember that if you ever have a radical like root negative 4, that's going to be 2i, right? The square root of 4 is 2, and then that negative gives us the I. Okay, that's still an option. That's stuff from section 2 that we learned about. All right, there is completing the square. The things that we want to remember is the b over 2 squared, and I've got them written right there. This right there, that's probably the hardest part to remember there, b over 2 squared. That's what goes in our blanks. All right, that's all.